Hey fellow problem solvers, Colfax Math here. Today we're going over chapter 2, fractions and decimals. This is part of a 25 chapter book that I'm working on. You could get the book to follow along. There'll be one video per chapter. In the book there will be a little bit of space for you to take some notes. The way you learn math is practice. You can't watch me juggle and expect to know how to juggle. You can't watch me do math and expect to know how to do math. You have to do the math. So follow along in that book, taking notes, pausing the videos, doing the problems before I do them. And again, today's videos, we're going to really look at fractions and decimals, conversions, and then we'll look at quite a few practice problems for any standardized math test. The point of this book is really to get you back in the game if you have some deficits in your previous math education. Okay, this is still part 1. There are 5 parts in this book. This is part 1, foundational skills. Chapter 2, working with fractions and decimals and conversions between the two. Adding and subtracting fractions. Surprisingly, adding and subtracting fractions is harder than multiplying them, even though they're earlier on in the curriculum. So if you want to add fractions, you got to think about what a fraction is. A fraction has a numerator like 2 and a denominator 5. It is saying if there are a total of 5 parts, you have 2 of those 5 parts. You cannot add fractions together unless they have that common denominator. Adding fractions with the common denominator is pretty easy. So if I have 2/5 plus 1/5, the denominator is that bottom number. If it is the same, I just add across the top, 2 plus 1, and I keep the bottom the same. And a lot of these, I just think about one I know the answer to, right? If I have 1/2 plus 1/2, I know the answer is going to be a whole. Following the rules of fractions, 1 plus 1 is equal to 2. I have that common denominator, I just keep it, 2. 2 over 2 is the equivalent of 1, right? 2 goes into here one time, into there one time. So I reduce that to 1. So if I ever kind of lose track of how to do a math operation, I go to an example that I know the answer of, and I kind of check that operation there. Okay, now we're getting to adding and subtracting fractions with different denominators. To add fractions with different denominators, you have to find a common denominator. The bottom number has to be the same. The least common multiple is often used. So here's an example. If I have 1/3 and 1/4, 1/3 plus 1/4, I cannot add those together. They don't have the same bottom number. What is the least common multiple? What number, the smallest number, the smallest number that they will both go into? They both won't go into 6. They both won't go into 8. The smallest number they will both go into is going to be 12. So how do I get this 4 to be a 12? I have to multiply it by a 3. So I'm going to multiply it by a 3. So I want to multiply that by 3 to get it to be a 12. And I want to multiply this by a 4 to get it to be a 12. However, I can't just multiply something by 3. It's going to change the value of it and not make any sense. The only thing I can multiply it by is a value of 1, so it doesn't change the value. So if 3 is there and 3 is here, 3 over 3 is 1, remember previous example. Now I am multiplying by a factor of 1, doesn't change the value. So I'm going to multiply this by 1. That's going to give me 3 over 12. Same thing right here. I can't just multiply by 4. I have to multiply by a factor of 1. Doesn't change the value of it. That gives me 4 over 12. I now have that common denominator. I can add across the top to get 7. Keep that denominator the same, 12. It's actually not that bad if you think it through a little bit. Otherwise, it is kind of a funny way to do something. But the key takeaway here is you could only multiply by 1 so as not to affect the value. To add and subtract, the key is the bottom number has to be the same. Okay, subtracting fractions. The same principles apply to subtraction. Find that common denominator. And then subtract a numerator. So here's an example. If I have 5/8 minus 1 quarter. The least common multiple here is going to be 8. I already have that 8 there. I don't have to do anything to the 5/8. This I need to multiply by 2. I can't just multiply by 2. It'll change the value, so I multiply by 1. 2 and 2 up above. And that gives me 5/8 minus 2/8. Common denominator. I am now subtracting, not adding. That's going to give me 5 minus 2, 3, over that common denominator, 8. So subtraction is really the same thing as addition. You're just going to use the operation subtraction, but you still have to have that common denominator. All right, moving on to section 2.2 in this chapter, multiplying, dividing fractions. To multiply fractions, you just multiply across the top, multiply across the bottom. So let's go ahead and do this example right here. If I have 2/3 times 4/5, that little asterisk right there we're using is a multiplication symbol. So I have 2/3 times 4/5. I just multiply across the top, 8. Multiply across the bottom, 15. My answer is 8/15. I do look to see if there's any number that would go into any of these so I could cancel. And there is no number here. I could cancel early on or when I'm done. Okay, now we have a mixed number here. Oh, no, we don't. Sorry. First, we're going to look at a whole number. So we're multiplying by a whole number. So let's take 3 times 1/4. 3 is really the same thing as 3 over 1. 3 divided by 1 is still 3. So a whole number is 3 times 1/4. Nothing could cancel. Multiply across the top. Multiply across the bottom. If I stop and think about that for a minute, I'm saying I have 3 quarters. How many quarters do I have? I have 3 quarters. Okay, dividing fractions. Dividing fractions is a little bit different. Dividing fractions is kind of this funny algorithm. The way you divide fractions is you multiply by the reciprocal. So you take that second number and you flip it over and change it to multiplication. So if I have 1/2 divided by 3/4, that is the exact same thing as 1/2 times the reciprocal. Reciprocal means flip it over. 1/2 times 4/3. All I did was I flipped that thing over. I can multiply across the top and across the bottom and I'm done. I could cancel. Multiply across the top 4, across the bottom 6. I do notice that 2 will go into here twice and 2 will go in here 3 times. These are the same answers, 4, 6, and 2/3. The only difference is this one is reduced. So they are equivalent, but this is a reduced answer. The other way you could reduce earlier on is see that 2 goes into here 1 time, 2 goes into here twice. Reduce in this part of the problem, multiply across the top 2, multiply across the bottom 3. Okay, I know a lot of information. Let's move on to decimals. There's a lot of practice problems at the end, but we'll go over decimals here. Okay, so decimals represent parts of a whole just like a fraction does. However, they are parts of 10 or tenths or 100. So understanding place order is really important. So if I have a number like 0.125, this is my tenths place, 1/10. This is my hundredths place because 0.12 is 12 100. 100 total parts, and it is 12 of the 100. The 5 is a thousandths place because it is 125 of 1,000. Now that we have the places of our tenths, hundredths, thousandths, understood? Let's take a look at adding and subtracting decimals. So if I had 3.14 plus 1.2, what I have to do is I have to line up that decimal point to add. So those decimals have to be lined up. Then I just add from right to left. 4 plus nothing there would be a 0. 4 plus 0 is 4. 1 plus 2 is 3. The decimal point comes straight down. 3 plus 1 is 4 to give me 4.34. If I was subtracting, same thing. I would have 5.75 minus 2.5 that decimal has to line straight up. I am subtracting now. There's no number here, so that would be a 0. 5 minus 0 is 5. 7 minus 5 is 2. 5 minus 2 is 3. Decimal place comes straight down right there. Okay, multiplying and dividing decimals. Now you got to keep track of how many places over the decimal is, and then continue that in your answer. So the way I'm going to do this is I'm going to take 2.3 times 1.5. 5 times 3 is 15, carry the 1. 5 times 2, 10, plus 1, 11. Placeholder, 1 times 3, 1 times 2. I add straight down, 5, 4, 3. So 23 times 15 is 345. Then I count how many places over the decimal is. It is over one place here, one place here. So the decimal starts here and goes over one, another, and the answer is 345, or 3 and 45 100ths, 3.45. So keep track of the decimals and transfer that to your answer. Down here I have 4.5 divided by 0.5. And clean this up a little bit. And the way I'm going to do that is keep track of the decimals as well. So I have 0.5 goes into 4.5. I want to turn this into an integer, so I'm going to move that decimal place over once. If I do that, I move this over once as well, and then this goes straight up. 5 goes into 4, it doesn't. 5 goes into 45 9 times evenly, and it's going to be even 0, so 9. So 4.5 divided by 0.5 is 9. Okay, section 2.5, chapter 2, 5th part, right? It's a decimal system, splitting the chapters up. So I want to convert a fraction to a decimal. I have 3/4 like this. I always think of it falling over to the right, like it falls over that way. So I want to know how many times 4 goes into 3. Well, 4 does not go into 3, so I'm going to have to put a 0.0 there. 4 goes into 37 times to give me 28. 30 minus 28 is 2. Bring down the 0. 4 goes into 25 times. That decimal place goes straight up. So 3/4 is 3 divided by 4, or 0.75. Those are all equivalents. And then let's do that second example there. Clean this up, a little bit of room to work. Again, this is a book I'm writing right now, so you could actually buy this book, have it in front of you, and mark it up with your own notes as I go through it. I'm still working on a few more edits. I don't want any mistakes in there. I'm sure there still will be mistakes, but I want to minimize them. So I want to convert 1/3 into a decimal. That's 1/3. It falls over that away. So how many times does 3 go into 1? It doesn't. So I got to go 1.0, bring that decimal place up. 3 into 10 3 times. That gives me a 9. 10, right? And I could see a 9, 1, bring down the 0. And I could see it's just going to be the same thing again and again. So, right? So what I do, rather than have to write all that out, I could just put a bar on there. And that bar says 3.3 repeating. It just keeps going on indefinitely. All right, converting decimals to fractions. So to convert a decimal to a fraction, remember this is parts of 100. So 0.25, right, this is my tenths, this is my hundredths. So 0.25 is 25 100ths. So there's my fraction. And all I need to do now is simplify it. I know 25 goes into here once, into here 4 times. So 0.25 is the equivalent of 25 100ths, or 1/4. Those are all the same value. Again, this is my tenths, my hundredths, my thousandths. So 125 over 1,000 is the fractional equivalent of 0.125. And I just want to start reducing that. I could see that 25 goes into here 5 times. 25 goes into here. How many times does it go in there? 200 times. And then how many times does 5 go into? 5 will go into 5 1 time, into 208 times to give me 1/8. These are all equal, 0.125, 125, 1/1000ths, or 1/8. They're all equal. This is just a simplified fraction of that. All right, let's take a look at percentages now. This is a symbol for percent. It is just part of 100. So it is just kind of telling you when you're in a percent, it's telling you the denominator of that fraction. 50% is 50 parts of 100, 50 over 100, which reduces to 1/2. So you could represent it. All of these are equivalent. 50% is the same thing as 50 over 100, reduced is 1/2. So if I say I had a quarter and I wanted to turn it into a percent, I would do 1 divided by 4. That's that quarter. That fraction falls over 4 into 1. It goes into 10 2 times to give me 8. 2 comes down. 10 minus 8 is going to give me a 2. Bring down the next 0. 4 goes into 25 times. Here's my decimal. It comes right up there. 1/4 is the decimal equivalent of 25 or 0.25. And then I remember this thing right here is if I'm going that way to turn it into a percent, I shoot it over 1, 2. So 0.25 is the equivalent of 25%. So that's how I go from a fraction to a decimal to a percent. If I have a decimal already, like 0.75, and I want to convert that to a percent, this decimal goes over 1, 2 to give me 75%. If, on the other hand, well, here, let me move the screen up, and then we'll do percentages to fractions. All right, so write the percent as a fraction. So the first thing I'm going to do right here is I'm going to take that 60%. I see this percent sign like an arrow shooting it over that way. So to me, it looks like it's shooting it over 2 places. So 60%, I go over 1, 2 to get 0.60. So that's percent to decimal. And then remember, this is my 10 is my 100 place. So this is the equivalent of 60 over 100. Zeros will drop out. 2 will go into there 3 times, into there 5 times. So 60%, 0.60, and 3/5 are all equivalent. If I have 35%, the equivalent of that is 0.35 as a decimal, or 35 1/100ths, both divisible by 5. 5 goes into there 7 times, into there 20 times. I can't reduce it any lower than that. All right, let's start working on some practical word problems now. These are pretty similar to ones you'll see on both arithmetic reasoning on the ASVAB and mathematical knowledge. A recipe calls for 2/3 cup of flour. I always circle the important numbers. If you want to make half the recipe, how much do you need? Well, half of that is going to be multiplication. It is multiplication of fractions. 2/3 times a half. I can multiply across right now and get 2 6. Or I could see 2 goes into there once, into there once, and I could see the answer is 1/3. John ran 3/4 of a mile, and Mary ran 1/2 of a mile. How much did one go than the other? Well, that's going to be the difference. So I have to do 3/4 minus 1/2. I don't have a common denominator. I need that common denominator. I'm going to multiply by 1 so as not to affect the value. I now have 3/4 minus 2/4 to give me 1/4. There's my answer right there. Here's one more example here. I have 5 pizzas. Each pizza is cut into 8 slices. How many slices do you have in total? Well, you have 5 pizzas, 8 slices per pizza. So I'm going to take that 8 number of slices per pizza, multiply by the number of pizzas to get 40 slices. A shirt costs $15.50 and a pair of pants costs $22.75. What's the total cost? I read that as addition. So I have to add that and that, lining up my decimal points right there to give me 38.25. Here are a couple more example problems, and if you have the book, you can work your way through those. And then here are just some practice problems with fractions. I'll go ahead and roll through a couple of these. Again, I would pause the video, go ahead and do them on your own first, and then unpause, watch how I do them. So I have 1/4 plus 2/4. I have that common denominator. I add across the top, keep that denominator the same, 3/4. Subtraction, common denominator is already there. 3 minus 1 is 2, common denominator of 5. Still fraction addition, but this one's a little bit different. I have 1/3 plus 1/6. Different denominators, I got to multiply that by 2 over 2 to get 2, 6 plus 1, 6, or 3, 6, reducing to 1/2. Number 4, I have 2/3 minus 1/4. I have to use my least common multiple, which can be 12. So I'm going to multiply this by 4 over 4, this by 3 over 3. That's going to give me 8/12 minus 3/12, or 8 minus 3, 5/12. Pen's not working here, 5/12. Multiplication, 1/2 times 3/4, multiply across the top, 3/8. Same thing here, 2/15. This one's a little harder, 7's a little different. I have 1/2 divided by 3/4. Where I divide fractions, multiply by the reciprocal, 1/2 times 4 over 3. 2 will go into here once, 2 will go into here twice. I could reduce first to give me 2/3. So this is 2/3. I have some problems on mixed numbers right here. I'll leave the answers in the book, but I'd work your way all the way through those. I'll skip down to some more problems here. And here's an overall kind of test on this section. So what I would do here is I would pause the video and then do these 6 problems. If you get all 6 right, then you know what's going on in this chapter. Unpause the video and then watch how I do them. Okay, number 1, 2/5 plus 1/3. I am adding fractions. I need that common denominator. Least common multiple is going to be 15. I multiply this by a 3 over a 3, this by a 5 over 5, multiplying by 1, doesn't change the value, I know I say that a lot. So that's going to give me 6 over 15 plus 5 over 15. Have that common denominator, multiply or add across the top, 11 over that common denominator of 15. That's my answer there. 7/8 minus 1/2. Again, I need a common denominator. Least common multiple is going to be 8. So I'm going to multiply my second term by 4 over 4. That's going to give me 7/8 minus 4/8. 7 minus 4 is 3. Keep that common denominator. Number 3, 3/4 times 2/5. Multiplying fractions go straight across the top, 6/20. I could reduce because both of them are even. 2 will go in each of them to give me 3/10. Or I could have reduced earlier. Either one's fine. Number 4, 1/3 divided by 2/3. The way I divide fractions, multiply by the reciprocal. So this is the equivalent of 1/3 times that thing flipped over. This time I'm going to cancel first. Multiply across the top, 1, across the bottom to get 1/2. Convert 5/8 to a decimal. A fraction falls over this way. How many times does 8 go into 5? Well, it doesn't. So we've got to check 50. 8 into 50, 5 would be 46, would be 48. Right? This was 5, so I got to make sure I have a decimal there and bring that decimal up there. 2, bring down the 0, 20. 8 into 20 twice, 16. 40, bring down the 0, 5. So the decimal equivalent of 5/8 is 0.625. And then I guess because we've already done this, number 6 is easy. 0.625 back to a fraction. There's a fraction right there. All right, if you're new to the channel, think about subscribing. I'm going to try and get 1 or 2 of these videos out a week. I'm going to try and be live so you can post your comments when the videos go live. I'm trying to work on finishing up that book and also have a live session some evening a week so you could just ask me questions and I could do them live on the screen here. All right, well, I really appreciate you watching. If you know anybody else who might need to take a free math course to get themselves back in the game, please go ahead and send this video on to them. And in the description, I'll link all of the videos. Again, it's a work in progress. I'm doing about the best I can at the pace of this. Thank you.